Hello and welcome to CodeByte's first video. In this video, we're going to be talking about Java and its history. Firstly, let's talk about its origins. So Java was released in 1995. There are quite a few languages that came out before it. For example, in 1883, the first actual language was created. Then Autocode in 1952, Fortran, Algo, COBOL, Lisp, BASIC, Pascal, Smalltalk, C, and SQL, and so on. So the story of Java's creation begins early in the 1990s, a time of rapid technological advancement. It was during this period that Sun Microsystems, a company that had a name for itself in the tech industry for the high performance workstations and servers, embarked on a new project. The project was spearheaded by three of Sun's engineers: James Gosling, a Canadian computer scientist known for his innovative ideas, Patrick Naughton, an engineer with a knack for problem solving, and Mike Sheridan, a seasoned professional with a wealth of experience in the tech industry. Together, they formed a formidable team, each bringing their own unique skills and perspectives to the table. Their project was initially named Oak, after the tree that Gosling could see from his office window. The aim of this project was not only just to develop another piece of software, but to create a new kind of software that could be used in consumer electronics and a market that was just beginning to take off at that time. The team wanted to create a software that was robust, secure, architectural neutral, and portable, characteristics that were not commonly associated with software at that time. So this vision kind of led to the creation of Java, like a programming language that would revolutionize obviously the software industry, and so many people use it now. So the birth of Java in the year of 1995, a significant shift occurred in the project. The team decided to rename the project from Oak to Java, drawing inspiration from the coffee that was consumed in copious amounts by the development team. The name change marked a new chapter in the project's journey, symbolizing the team's relentless dedication and the countless hours of work fueled by their love for coffee. The team's efforts culminated in the release of the first public version of Java, known as JDK 1.0, on January 23rd, 1996. This is a landmark moment not just for Sun Microsystems, but for the entire tech industry. The release of JDK 1.0 marked the official birth of Java to the world, a programming language that, as I said before, has impacted the world in many ways. So Java's introduction to the public was met with a lot of acclaim. Developers around the world quickly recognized the potential of this new language with its promise of write once, run anywhere, which stands for Wora. Today, Java continues to be a dominant force in the world of software development, a testament to the vision and hard work the team at Sun Microsystems. One of the key principles that contributed to Java's rise in popularity, as mentioned before, was the Wora, but also it was applets. They were small Java programs that could be embedded in web pages, which kind of brought interactivity and dynamic content to the static web of the 1990s. Applets played a pivotal role in demonstrating Java's capabilities for web development, which kind of helped establish Java as a leading language for building web applications. Java's success was not limited to the web. However, its robustness, security, and scalability made it like an ideal choice for a diverse range of domains, um, for enterprise softwares to mobile applications and embedded systems. Java proved its versatility and adaptability time and time again. Its ability to meet the demands of such a widespread variety of applications further cemented itself as the main programming language for many people. In 1998, the JCP, or the Java Community Process, was established to guide the evolution of the Java platform. The JCP presented or represented an open collaboration among industry stakeholders, including developers, academics, and businesses. Though through the JCP, the Java community had a voice in shaping the future of Java, ensuring that the platform continued to evolve and meet the changing needs of the industry. Okay, now let's talk about some Java rules. So Java's sensitivity is a defining characteristic of the language. It is statistically typed, meaning that the type of each variable is checked at a compile time. This feature aids in catching errors early during the development process, thereby enhancing the reliability of the code, and it ensures the developers adhere to strict naming conventions and promotes clarity and precision in the code. One of the most celebrated features of Java is its platform independence. Um, this means that Java programs can run seamlessly on any device equipped with a JVM or Java virtual machine, making the language highly portable. This feature has been instrumental in like Java's widespread adoption everywhere, as it allows developers to write code and deploy it across multiple platforms without modification. Java is also known for its object-oriented programming paradigm. This approach structures the program around objects rather than procedures, promoting modular and reusable code. It allows developers to create complex applications with increased stability and flexibility. The object oriented nature of Java encourages encapsulation and inheritance and polymorphism, which we're going to talk about later in the course. But these principles kind of left or led to like a cleaner and more efficient code. Lastly, Java boasts a rich standard library, providing developers with a vast array of pre-written code to simplify many programming tasks. From networking to data structures, the standard library is a treasure trove for like utilities that can expedite the development process and reduce the complexity of the code. This comprehensive library is one of the reasons why Java continues to be a preferred choice for developers around the world. It not only saves time, but enhances the function of Java. Let's look at an example. Shown below are two very similar like lines of codes. The one on the left says system.out.println hello world. Um, it essentially says to print the statement hello world on a new line as the output. Um, though this will give you a syntax error because there's no semicolon at the end of that line of code. A semicolon acts as, think of it as if the computer is reading the line of code and the semicolon acts as a brick wall. So it kind of tells the computer that, okay, this is the end of that line of code and it's going to go on to the next line and read that. Since there's no semicolon, the computer is just going to keep on reading that line. And if there's nothing else after it, then it's just going to give you a syntax error. The one on the right says system.out.println hello world with a semicolon, and this will not give you a syntax error and will print out hello world. Now let's talk about Java structure. Java is an object-oriented language, structures its programs around objects, which are organized into classes. These classes serve as blueprints for creating objects, encapsulating related data and behavior. A class in Java that is typically declared using the public keyword, which signifies that the class can be accessed from any part of the program. This accessibility kind of promotes flexibility and interaction between different parts of the code and helps you tremendously when doing different programs. Within these classes, we can define fields or variables that hold the state of objects. These fields can be declared as private, meaning that they are accessible only within the class they're declared in. This encapsulation ensures that data integrity by preventing unauthorized access and modification of the data. A special method called a constructor is used to initialize objects of that class. The constructor typically shares the same name as the class and is often declared as public. This allows it to be accessed when an object of the class is created, ensuring that the object is in valid state from the moment of its creation. So methods, which are kind of functions that belong to a class, they kind of encapsulate the behavior of the objects and they can be declared as public, which allows them to be accessed from anywhere in the program. These methods provide a way to interact with objects, enabling operations like reading and modifying the object state. Now, not everyone has to use methods. It is sometimes better to use methods, but as you'll see when we go on further down the course, there are times when you should use methods and times when you should not use methods. So, in summary, Java's object oriented design, with its classes, fields, constructors, and methods, provides a structured and intuitive framework for building robust and reusable code, which kind of boosts Java's credibility and usability.
So in Java, we have 8 primitive types, and these primitive types include byte, short, int, long, float, double, boolean, and char. These types serve as the building blocks of data manipulation in Java. However, in these primitive types, we'll mainly be focusing on uh, four primitive types, which include int, double, boolean, and char. To give you guys some brief context about these primitive types, int is used to store integer values, double is used to store decimals, boolean is used to store true or false, char is used to store a single character. So let's first go into integer, which is int. Int represents integers which can either be negative or positive numbers. For example, an int variable can be written as int p equal to 3. So in this example, p is our variable. And right before the p, we see that there's an int. So the int tells us that this variable p is an integer. Okay? And we'll have an equal sign. It's called an assignment operator, which I'll be telling you guys later in this presentation. But the equal sign tells us that, okay, p is equal to 3. So the numerical value that p has is 3. Okay. The next primitive types we'll talk about is double and char. First, let's go into double. Uh, int doesn't support decimals, however, double does. Double can be written instead of an int to give decimal points. So the reason double can hold decimals and ints can't is because doubles have more space and more bits than compared to int. So let's look at this example. Double p equal to 3.25 semicolon. So we have a variable p, and the primitive type is double because it's right before the p variable, and its numerical value is 3.25, as we can see with the equal sign. So the equal sign allows the double p to have a value of 3.25. So next we have char. So to write words, we use string, which is not a primitive type, and we'll go over strings in the future of this course. However, we use char in order to write one letter or one character. Char represents character. Let's look at this. So example could be char a equal to apostrophe a apostrophe. So if we use a quotation mark, for example, that represents a string. But however, if we use an apostrophe, that's a char. So it's really important to know the difference between char and string. I know we haven't gone through string yet, but we will go through string in the future. So we have 5 arithmetic operators. They include addition, subtraction, multiplication, division, and modulus. So first, addition. Addition can be written with the plus sign. The plus sign can help add two numbers together, but it can also concatenate two statements together, which we'll be going over in the strings topic. We also have subtraction, which is the minus sign. The minus sign helps subtract two numbers together. And we have multiplication, which we can use a star to multiply two numbers together. And division, we could use a slash to divide two numbers together. We also have modulus, which if we're doing 7 mod 3, for example, right? We could do that will get us 1 as the answer. Modulus basically finds the remainder of two numbers. We are, as stated before, we also have something called the assignment operator, which is the equal sign. So the assignment operator basically assigns a value to your variable, as stated earlier. So let's look at an example with arithmetic operators. So let me read this to you guys. Int tiger equal to 9, int lion equal to 7, int wolf equal to tiger minus lion, and then we do system.out.println wolf, semicolon. Okay. So we're printing out wolf, right? So we first have to know what the value of wolf is, right? So we go to the wolf. line. Okay, this tells us int wolf equal to tiger minus lion. So we're subtracting tiger minus lion, right? We have to find the numerical value of both tiger and lion. The numerical value for tiger is 9. The numerical value for lion is 7. Okay? So what is 9 minus 7? It's 2, right? Let's double check. Yeah, it's 2. Okay. Last but not least, we have commenting. So we use double slash to comment a line, and we use slash star and star slash to comment a paragraph. So let's look at some examples. First, we have an apple a day keeps the doctor away, and it's commented out with double slashes. As we can see from this example, it only commented out a line of code. Okay. Now let's look at how we can comment out paragraphs. Okay. We use slash star shopping list and then milk, apples, orange, celery, and then star slash. So this just tells us that this shows that we can comment a paragraph. So there's benefits to both. So if we want to comment less, we should obviously use double slashes. However, if we are using like commenting out essays, for example, we should use the group comments. And comments are really beneficial in the IT industry because they help give further information about a certain topic, right? And uh, for example, take this, right? We have the Mona Lisa, for example, right? Underneath the Mona Lisa, there's a written text, right? Like a caption. Similar with Java, commenting is basically that caption we have. It basically gives us um, the brief information about a certain line of code, a certain method, a certain class. So for that reason, it just simplifies the work for the programmers and IT professionals in this field. And lastly, we have increment slash decrement. Okay, so increment is basically equal to I plus plus, and decrement is equal to I minus minus. So I plus plus can also be written as I equals I plus 1. We're incrementing it by 1. Okay, remember that. And decrement, we can also, for example, if we take the variable I, right, we could do I equals I minus 1. We are decrementing by 1. So let's look at some examples. Okay, this example we are incrementing, this example we are decrementing. Okay, so the first example we are given is I equals 2, and then we have a semicolon, and then we do I plus plus. Okay, so what is 2 plus 1? Since we're doing I plus plus, right, we have to increment by 1. 2 plus 1 is 3. Okay, same with this. We are given I equals 2, and we are decrementing, right? We're not incrementing, we're decrementing. And 2 minus 1 is 1. So over here, 2 plus 1, when we're incrementing, is 3. And then 2 minus 1 is equal to 1.